In this problem, we have an augmented matrix for a system of linear equations x, y, and z is given. We need to find the solution of the system. So when we're given a problem like this, we're going to write out a few things before we start. First, we have this first column, which is the x column. We have our y column, and then we have our z column. Lastly, we have the number column, and that's not really going to change anything. But when we write our x, y's, and z out, we're going to rewrite all of our columns, but with the x, y, and z. So we are going to have a 1x plus a 2y plus a 5z, and this is equal to a negative 12. Now we're going to do the same thing where we have a 2x minus 2y plus 4z, and this is equal to a negative 6. And lastly, we have a 0x, and then we have a 1y, and then we have a negative 3z, and this is equal to 13. We need to identify a base case. That's one of these solutions. So we have solution 1, or we have equation 1, we have equation 2, and we have equation 3. If we have a base case here, we need to solve for everything connected to it. So like, let's say 1 is our base case. Then we are going to solve for these two. And then we're going to use 3 here. So we're going to add 1 and 2 together, and then we're going to add 1 and 3 together. What we cannot do is add 2 and 3 together because it does not involve our base case. And this would go if we chose 3 or 2 as our base case as well. I'm going to choose 1 as our base case. So if I choose 1 as our base case, it looks like we're going to get rid of the y's. So putting these together, I'm going to have a 3x, our y is going to 0 out, and we'll just be left with a plus 9z. And this is going to be equal to a negative 18. And after this, we are going to do the bottom case where we have our 1 and our 3 added together. We want to get rid of the y in our 3, so for the third one, we're going to multiply it by negative 2. If we multiply this by negative 2, we are going to, well, originally have x plus 2y plus 5z is equal to negative 12, and then multiplying the negative 2 in to the bottom part, the third part, we're going to have negative 2y plus 6z is equal to negative 26. Now we add these together, we're going to get x plus 11z is equal to negative 38. And now we can bring this up here under this part. So we're going to have it look like this. And now we can add these together. Well, we want to get something to cancel out. Now, the easiest way to do this is actually divide the first part. Normally you would think, oh, I can just multiply a negative 3 to the bottom and then the x's will cancel out. Well, it's a little bit easier if you just multiply the top by negative 1 over 3, and this is equivalent to dividing the entire top by a negative 3. So if we do this, we are going to get a negative x minus a 3z is equal to 6. And that's the whole top divided. We're going to bring this part over here. So we're going to have an x plus 11z is equal to negative 38. And remember, we are still adding these together. If we had a negative x to a positive x, we're just going to get 0. If we had a negative 3z and a 11z, we're going to get 8z. And this is going to be equal to a negative 32. So our z is going to be equal to negative 4. And that's how we would solve for that. Now we are going to solve for the next part. And when we solve for something like this, we're just going to start from here and we're going to look back up. And we can see if we look at these two equations, we can actually plug our z in, and then the only variable that we will not know is our x. So the easiest thing to plug in here for is this first one that we have right here. Technically, this is going to be the fourth equation since we have 3 over here. So this is going to be equation 4. We're plugging it into equation 4. So for equation 4, we have a negative x minus a 3 times a negative 4, and this is equal to 6. We'll have a negative x. We are going to have a positive 12, and that's equal to 6. So we can subtract 6 from both sides, and then we can also add x to both sides. If we do this, we are going to get 12 minus 6, so that would be 6 is equal to x. So our x is equal to 6. Now that we have this, we can plug it back into our first or second equations, one of these two. And I'll just plug it into the first one for simplicity. So our x is 6. We are going to have a plus 2y. So we'll have that there. And then plus 5 times our z, which is negative 4. And this is equal to negative 12. Well, if we add everything together, so we'll have a 6 plus 2y, and then we are going to have a minus 20 is equal to negative 12, we can see that everything is divisible by 2. So we're just going to multiply this by 1/2. We are going to get a 3 plus y minus 10 is equal to negative 6. We are going to add like terms, so we're going to have a y minus 7 is equal to negative 6. We're going to add 7 to both sides, and that means our y is equal to 1. And that will give us the answer. That's how we would go about solving for this problem.